I am Pooja, your physics teacher. As per the new syllabus, we will start our first topic, that is rotational dynamics. Now, rotational dynamics. What do you mean by the dynamics first? Now, what is dynamic? It is the branch of physical science which deals with the motion of object. That means that any object, when it is in motion, that motion is circular path, linear path also, etc. Now, in this dynamics, the motion of an object, we study first the circular motion. Now, what do you mean by the circular motion? We will see first circular motion. For example, here I will draw the circle. This is the center of a circle. Here P is the position of a particle. That particle is moving along the circumference of a circle. The motion of that particle is circular motion. That is, in overall, when a particle is moving along the circumference of a circle, that motion is known as the circular motion. For example, motion of an earth around the sun. Around the sun. This is one of the circular motions. Motion of a satellite around the earth. This is also the circular motion. Motion of a fan. This is also the circular motion. That means that in our day-to-day life, there are many more examples of circular motion. Now, these characteristics of circular motion. There are mainly two characteristics of circular motion. First one is, it is an accelerated motion. And second characteristic is, it is a periodic motion. First characteristics, how it is accelerated motion. Accelerated motion means as the direction of velocity changes at every instant, it is an accelerated motion. Now we will see the example of this. Suppose this is a circular path. O is the center of a circle. In this circular path, here P is the position of a particle. This particle P is moving along the circumference of a circle in anti-clockwise phase. This is a circular path. If this particle is here at position P, its direction is like that, and it is tangential to the circular path. If this direction changes like this, the direction of velocity is like this. Now, if this particle is moving here, its direction is tangential to this surface, and the direction of velocity also like this. Here, if this particle is moved here, the direction is like that. Here, this is also tangential to the surface. Means, the direction of velocity also changes. Also, this particle is moving here. The direction of particle is like that, and the direction of velocity also changes. That means that as the particle is moving along the circumference of a circle at any point, it changes its direction at every instant. As the direction changes, it changes its velocity at every instant. And as the direction of velocity changes, its acceleration also changes. And that's why it is an accelerated motion. The second characteristics of circular motion, that is, it is a periodic motion. Now, what is periodic motion? Periodic motion, during periodic motion, the particle repeatedly moves along the same path. That is the periodic motion. So, during this motion, a particle repeatedly moves along the same trajectory. That is the periodic motion. In this periodic motion, how the particle moves along the same trajectory? For that, we will see the example of simple pendulum. This is a bob of a simple pendulum. That is also called as the spherical bob. Here, this bob is suspended from this rigid support. Here, OA is the mean position of a simple pendulum. Now, this bob moves from this position B here. Now from B to A here, and now from A to C here, and then C to A. That means that the bob is moving along the same path again and again. That is, it completes one oscillation here. The path covered by the bob, like that, AB plus BA plus AC plus CA. It completes one oscillation. So, such a oscillation takes place again and again along the same path. That means that it is a periodic motion. The motion of that bob is a periodic motion. We will see the kinematics of circular motion. Kinematics of circular motion. Now, what do you mean by the kinematics? Kinematics, it is the study of object in motion, that is velocity, acceleration and momentum. मध्ये आपण हा ऑब्जेक्ट जो आहे मोशन मध्ये येताना त्याची व्हेलॉसिटी, ॲक्सेलरेशन, मोमेंटम या टर्म्स आपण याच्यामध्ये बघणार आहोत. नाउ as seen in the 11th standard, in order to describe a circular motion, there are some quantities in linear motion and in circular motion. In linear motion, displacement is represented by S, and in circular motion, this is the angular displacement, which is represented by theta here. Second quantity in linear motion, that is velocity, which is represented by V here. Second quantity in circular motion, this is the angular velocity, which is represented by omega. And third quantity is here acceleration, which is represented by small a. Here in circular motion, this is angular acceleration, and this angular acceleration is represented by alpha. Now, what is this theta, alpha, theta, omega, alpha? These are the Greek alphabet, like alpha, beta, gamma. आता आपण याच्यामध्ये डिस्प्लेसमेंट, हे लिनियर डिस्प्लेसमेंट झालं, हे ॲनालॉगस आहे कशाशी? अँग्युलर डिस्प्लेसमेंटशी. तसंच ही लिनियर वेलॉसिटी झाली, ही ॲनालॉगस आहे कशाशी? अँग्युलर वेलॉसिटीशी, जी आपण ओमेगाने रिप्रेझेंट केली. आणि इथे ॲक्सेलरेशन जे आहे लिनियर, हे ॲनालॉगस आहे अँग्युलर ॲक्सेलरेशन. नाउ वी विल सी दिस थ्री टर्म्स इन ब्रीफ. Angular displacement, theta. Now what do you mean by the angular displacement? The angle covered by the radius vector in a given time at the center of a circle, that is called as the angular displacement. It is represented by theta. So in this figure we show the theta, that is angular displacement. In this figure, O is the center of a circle. Here A is the initial position of a particle and B is a final position. We draw this radius vector. This is also the radius vector. Here in this figure, vector OA is the initial radius vector. Vector OB is the final radius vector, and the angle covered by the radius vector here, that is this theta, is called as the angular displacement. Now, how we can measure this angular displacement theta here? Theta equals to arc upon the radius. So, here in this figure, arc is AB and radius is R. So, by using this formula, we can calculate the angular displacement theta. And this angular displacement theta is measured in radian here. Now, we will see the angular velocity, that is omega. Angular velocity omega. Here, what do you mean by the angular velocity? The rate of change of angular displacement with time is called as angular velocity. So, angular velocity vector omega is equal to the rate of change of angular displacement, that is d theta, with time, that is dt. So, vector omega equals to d theta upon dt. Now, we will show the direction of this angular velocity. Direction of angular velocity by right hand thumb rule. So, see the right hand thumb rule. To know the direction of omega, we apply right hand thumb rule. Here, omega is always along the axis of rotation. So, the direction of omega is given by the right hand thumb rule. Show the direction of angular velocity. We will draw this two diagram. This is figure A. In figure A, the particle is moving in anti-clockwise sense. Now we will draw the figure B. This is figure B. In figure B, the particle moves in clockwise sense. Now, how we apply the right hand thumb rule here? Suppose this is our right hand. If the fingers of our right hand are curved, are rotated along the circular motion, then this stretched thumb represents the direction of angular velocity, which is in upward direction. So, the angular velocity is shown here in upward direction in this figure A. And now, the same rule is applied here in figure B. If these fingers are curved in clockwise sense, then this is the sense of rotation. This is clockwise, and this stretched thumb represents the direction of angular velocity, which is in downward direction. So, the angular velocity here is in downward direction. We will see the angular acceleration. Angular acceleration is represented by alpha here. Alpha is the Greek alphabet. Angular acceleration is the rate of change of angular velocity with time. That is called as the angular acceleration. So here we represent by alpha. So alpha equals to d omega upon dt. The rate of change of angular velocity with respect to time. This is the angular acceleration. We will see the types of circular motion. So there are two types of circular motion. First one is uniform circular motion, and second one is non-uniform circular motion. Now, what is uniform circular motion? In uniform circular motion, when the particle is revolving, the speed of the particle remains constant. That is called as the uniform circular motion. For example, the earth is revolving around the sun. That means that when the earth is revolving around the sun, its speed remains same. म्हणजे पृथ्वी जेव्हा सूर्याभोवती फिरते तेव्हा त्या पृथ्वीची स्पीड ही कॉन्स्टंट असते. It does not change. That's why this is called as the uniform circular motion. Now, what is non-uniform circular motion? In non-uniform circular motion, when the particle is moving, its speed changes. That is called as the non-uniform circular motion. For example, the car is moving in a circular race track. That means that when a car is moving in a circular race track, its speed goes on increasing sometimes it becomes decreases. So, the speed of a car does not constant here. That's why this is called as the non-uniform circular motion. We will see the types of circular motion in details in the next lecture. Till then, keep studying. Happy learning. Thank you.